Hi, I'm Larry Johnson. I am a professor at Texas A&M University, and today we're going to talk about cartilage of bone. We're talking about structures and functions, cells, types of bone, compact bone, remodeling, all the conversion systems, osteoclast action, epiphyseal plate, types of growth in length, summary, and questions. So here we can see in the embryo that we were cartilage. Our bone, our skeleton was cartilage at one time, and then it gets replaced, and then you have the epiphyseal plate where you grow. Before puberty, you start to grow, and the bone cannot grow from within. The cartilage has to grow, and then it's replaced by bone. And here we can see a compact bone which has these conversion systems. So this is the osteon, and then these osteocytes that are located in through there. And you have lamellae, circumferential lamellae. So this is the end osteum, periosteum that we have with the bone. So here's the cartilage at the end, and then you have primary spongiosa. It still have a cartilage core. You can see the blue core in there, but this is cartilage and this is bone with a little bit of cartilage in the various. It would be compact bone on either side, and it would be the perichondrium and the periosteum is the capsule. So we look again at you can see the densely regular connective tissue of the periosteum and the perichondrium. That we see the hyaline cartilage. We can see this is also where you have the fiber cartilage as well. If we look at the finger, at the growth plate, again we got the different zones: zone of reserve, proliferation, hypertrophy, calcification. So that's a repeating cycle of all the various different bones that we have at the growth plate, which would be right in through there. So cartilage. Primary spongiosum still has cartilage in it. And so are the different cells. The one cells on the side of these here are the osteoblasts. And the osteoblasts become osteocytes when they get trapped in their lacunae. Osteoid is bone. We can see all the pink here that we see here, compact bone. This is spongy bone in through here. The other cell is the osteoclast. Osteoclast is multinucleated cell that we see here. We can see it there, more than one nucleus, and that's the one that breaks down bone. And so this one breaks down bone, and osteoblast lays down bone. When the osteoid goes all the way around it, it's trapped in its lacunae, and it becomes an osteocyte. Osteoblasts give rise to osteocytes. So here we see cartilage. All this is cartilage in through here. These are chondrocytes. These are the osteoclasts. Yeah, you can see one there. You can only see a nucleus, one nucleus there. And these guys who trap the lacunae are the osteocytes. And this is compact bone. And this would be the periosteum that we see. A similar type thing there. Cells on the surface are laying down new bone, or it could be osteoclast eating up bone. There's the osteoclast that we see right there, osteocytes, and here we see the trabeculae, the projection that we see there are trabeculae, and we can see that this one still has its primary spongiosum because it still has a cartilage core. Here we see electron microscopic view of the rough endoplasmic reticulum, which is indicative of protein production, and bone is protein. Type 1 collagen is a main component of bone, and then you also have hydroxyapatite crystals, which is what crystallizes bone that makes it hard. Secretory vesicles that we see, they're secreting the type 1 collagen, and you have a large Golgi apparatus which puts a sulfur on the proteins that are produced in the rough endoplasmic reticulum to make collagen. So rough endoplasmic reticulum, Golgi apparatus, secretory vesicles, nucleus of these are osteoblasts. And here we look at toluene in blue. This is bone and through here, and this is cartilage. Don't worry about the different coloration. It doesn't matter. It was a staining problem. But here we see osteoclasts, which eat up bone. Osteoblasts, which are laying down bone. And this is a secondary spongiosum, doesn't have cartilage core in it. Osteoid is bone. Lacunae is the spaces that we can see there. Osteoclast, multinucleated cell, and these be osteoblasts, laying down more bone. Now, if you look at compact bone, there's several things. You got concentric lamellae. You got an inner circumferential and outer circumferential lamellae, and that was developed from appositional growth. And appositional growth is from the enosteum as well as the periosteum. So as a cell develops, it makes these layers here. In addition to that, you have the Haversian system. So this is a Haversian system here, and this is a Haversian canal. And the nutrients come through this canal, and it comes from the Volkmann's canal, from the outside through there, feeding the Haversian canal, which is where the nutrients go. And you can see this is a series of these Haversian systems, and they're long columns, and they run down the length of bone. They don't just run at random, they run down the length of bone. And what it is osteoclasts have gotten together and made a hole, and then the osteoblast fills in the hole. So here we can see one of these, which is just about a quarter of one, and you can see Haversian canal, cement, lacunae is the spaces, and lamellae are the projections between one cell, where one cell touches another cell and it gets nutrients from the gap junction. So from the Haversian canal comes blood vessels, and nutrients go through from cell to cell to cell by these lamina, by these caveoli. So these projections in through your caveola, these are different layers. One's laid down, another one's laid down. It lays down from the outside in, just the opposite of a tree for this Haversian system. Here we can see the Haversian system in ground bone. This is Haversian system here. Here's a canal. These guys here are the osteocytes trapped in the lacunae. Actually, what you see is a space, is a lacunae that we see, and you can see the canaliculi projecting from one cell to another, providing nutrients from the Haversian canal out to the various cells. We can see that again here. You can see the canaliculi, the lacunae that you can see, and inside there would be the different osteocytes. And so here you can see Haversian system. There's another one there, and as the bone is remodeled, it eats up some new ones and some old ones. Here again we can see this is the inner circumferential lamellae that you see there, and then we can see another Haversian system. Haversian system in through there with a Haversian canal. So inside compact bone would be spongy bone. So this stuff right here would be spongy bone. So another Haversian system here and here, where bone is remodeling. So this is a compact bone. This is a Haversian system, osteon, Haversian canal, lacunae, osteocytes that are located in through there, and the little spider legs into here are the canaliculi. Here we can see unstained bone. So these would be the Haversian canals. Haversian system will be around them. The Volkmann's canal is what attaches nutrients from the outside to the Haversian canal. Again, Haversian canals, and we can see osteocytes in through there in the Volkmann's canal. On this slide, we can see the osteoblast on the sides, which are laying down new bone. Osteoid, which is new bone. Lacunae, osteocytes are trapped in the lacunae, and osteoclast. Here's the osteoclast right there. Not there, that one's wrong, but this one and that one are osteoclast, osteoblast right there, but that one's wrong. Here we see the cartilage at the epiphyseal plate. So you have bone up there, bone here, and cartilage in between there, which is growing by interstitial growth to make bone longer. Bone gets wider by appositional growth, but it's interstitial growth that it grows by the length. Length is interstitial growth for the cartilage because bone can't do it. So the cartilage does it, and then it's transferred, made to bone. But the width goes by appositional growth. And so here you can see the different zones of the cartilage, as in the reserve, proliferation, hypertrophy, and calcification. See those again and again. Here we see primary spongiosa. The primary spongiosa has cartilage in its core. The secondary spongiosa has osteoid in its core that we can see right there. So all these different regions, you have proliferation by interstitial growth of cartilage. Then you have the alignment as the cells are proliferating. Then they hypertrophy, and then they calcify, then they're replaced. And that's just a cycle that goes over again at the epiphyseal plate. And the transfer of your cartilage skeleton to your bones. Here again, we can see the same type of thing with the different zones that we can see, the same different zones that we can see there. And the function of cartilage and bone, as we see in terms of summary, is in the embryo, we had a cartilage skeleton. Some sharks only have a cartilage skeleton. And then for you to walk on land with all that weight there, you definitely have to have some bones to keep your shape. Also, you can see the cells of the reversion system and the canaliculi, which allows nutrients to pass from one cell to another one, and of course the different zones of cartilage growth. A couple questions that may be of interest: which are true about endochondral bone growth? Endochondral bone growth is where bone is used cartilage model, and then bone develops from that. And one answer is growth in width occurs by appositional growth. This is true. Okay, the growth in length occurs at the epiphyseal plate by interstitial growth of cartilage followed by replacement bone. True. So bone can grow by appositional growth. It cannot grow by interstitial growth. Okay, and so secondary spongiosa has an osteoid core. True. So the answer is E. Cartilage differs from bone in diffusibility of extracellular matrix. That's true. Nutrients can diffuse through cartilage but not bone. The presence of isogenic groups. True, because isogenic groups are produced by interstitial growth, and cartilage has it but bone does not. Ability of appositional growth. False. Both have appositional growth. And so the answer is D, A, and B. Here we see Big Bend. This is actually, these are mountains of Mexico at the distance that we see over there. We want to thank the original source of several drawings, images, and figures that were used from these various textbooks. So we acknowledge the textbooks as being the original source of those materials. Thank you. That's the end of Cartilage and Bone Structures and Functions, Types of Cells, Remodeling of Bone, Epiphyseal Plate, Questions, and Summary. Thank you.